Okay, we are live now. Yep. Hey everyone, thank you so much for joining the session today. Before starting the session, I'd like to thank all the partners, Head Start India, Startup Grind, SaaS Insiders, and Google Developer Community Channel. And without any delay, I'd like to invite and also very warm to welcome our moderator, Mr. Arjun Rao, founding partner of Speciale Invest. Over to you, Arjun. Thank you so much for taking your time, and also warm welcome to all the panelists.
Thank you, Dhanush, setting this up and setting the stage. Right, super excited. Good morning, everyone uh, in the audience for joining this morning session, and thank you to the panelists for getting on board as well from all over the world, right, at weird hours. So thank you for that. This is our first attempt at having conversations with leading tech entrepreneurs and technologists in the startup ecosystem, right? To learn about their journey, to learn about specific aspects of what they're building and what the future holds in the domains that they're working in, right? And we call this series SpecialeTalks, right? Hosted by Speciale Invest. Just a quick introduction about us. We're a pre-seed seed fund focused on early stage deep tech ideas. We do a combination of enterprise software SaaS companies based on some unique technical insight and innovation, and we do enterprise / industrial hardware companies as well, also based on disruptive technical innovations. Right? We typically invest $500,000 to $1 million in the very early stage of a company and help these companies to with capital as well as going to market in the first couple of years, right? Being our sweet spot. We've been in operation close to about 3+ years and have closing in on 15 portfolio companies are in our kitty, and we look to continue to investing in this early stage ecosystem, primarily out of India, but also India, US cross-border is a strong flavor. We have a couple of our portfolio companies being represented today on the conversation, right? So that's a little bit about Speciale Invest. And welcome everyone to SpecialeTalks once again, right? We'll use the next 1 hour to have an interesting conversation. With that, I would like to introduce our panelists, right? Srivatsan Lakshman is co-founder, CEO at RuleArc, and conversational AI platform that enables small and medium businesses to enhance their business capabilities by handling customer conversations in real time. Right? Srivatsan has been in the AI world for closing in on maybe even as much as 20 years with a PhD from ISC, and has worked in his past life in AI research at Microsoft before getting onto the entrepreneurial journey. His previous startup also was in conversational AI, and now he's been working and building RuleArc over the last 4 years. Right, so we're super excited to have him here and understand what he's building. Srivatsan, thank you for being here and for taking the time out so late in the evening in Palo Alto.
Hey, hello everybody. Thanks, Arjun.
Our second panelist is Ruben Fuken, a dear friend that I've known for a long time, also been in this ecosystem for many, many years. Serial entrepreneur, worked very early in the data space in the early 2000s. Maybe the evolution of that is big data, and now today that is AI and machine learning. So we'll hear some very unique insights from him. Built his previous startup in big data analytics called Data RPM and had a very successful exit there. Also based out of the Bay Area, and now currently building an AI machine learning driven financial services product, which he will talk about as we go on. And very excited to have you here as well, Ruben. Thank you so much.
Hey, thanks, Arjun, and good morning, everyone. Really very excited to be here and be part of this discussion. So really look forward to it.
Thank you. Our third panelist, Shrikar, is CTO and co-founder at Wingman, right? Sales intelligence platform startup based out of Bangalore. building for the world. Shrikar has again a rich, more than a decade-long background in AI and machine learning. Prior to starting this company, I think has had exposure to machine learning and AI and building teams in this domain across large companies such as Google, Uber, and Amazon. Right, so there'll be some unique insights about how large companies use AI and machine learning and how they are using the same at Wingman. Right, super excited to have you here, Shrikar, as well. Thank you so much for being here.
Hey, thanks, Arjun. Hi, everyone. Looking forward to a very productive conversation.
Lovely. So we'll start off this freewheeling conversation by maybe a quick, small introduction from each of you, each of the panelists, about your particular startup, right? And how you're using AI and machine learning in solving what problem within your startup. That will be a good way to get this kick started. Maybe Srivatsan, if you can get started with that and how you're doing, what you're building at TrueLark and how AI and machine learning is used in the product. Over to you.
Sure. Thanks. Thanks again, Arjun. Thanks, and good morning, everybody. At TrueLark, we, is a company that was incorporated in 2017, and over the last 3 to 4 years, we've been focused on building automated customer communication platforms for local businesses. I mean, our motivation came from how the challenge of building such a wide variety of conversational agents, can be achieved through a unified platform. And we've built that AI required for such a solution ground up. We call it the Midgo AI framework. It's AI. It's a patented conversational AI technology which automates multi-turn goal-oriented conversations. And it's the exciting thing is it's remarkably human-like. And the interesting thing, I mean, of course, chatbots have been flooding the market. There's just a lot of chatter and noise around it. What is very unique and interesting about the work we are doing at TrueLark is that there's this outcome-based automatic labeling, together with humans in the loop, that generates very, very rich, granular teaching inputs. And I can go into some more details later, but it generates very granular teaching inputs for every turn of the conversation, allowing for very rich and deeply productive conversational interactions. And using that, we're able to build experiences that businesses can configure in many, many different ways from just a single unified platform. So with that, I'll just pause and hand the baton to maybe back to Arjun, to then go around the other companies that are on the panel.
Yeah, thank you so much, Srivatsan. That's a very exciting introduction and how we are trying to solve what is complex problem and what seemingly people have tried to explain that it is very simple with chatbots, but it is not. Anytime there is a human conversation, the nuance is detailed, human is unique, and solving it in the human-like fashion is the biggest challenge as far as we understand. Thank you for that introduction. We'll come back to you and maybe dive deeper later. All right. Ruben, would love to hear what you are doing. You're a little more early in your current entrepreneurial journey. So curious also, right? What you're building and how you're building that. Over to you.
No, absolutely. And thanks for having me as a part of this discussion. So my current startup is called Automated Returns. We are an investment technology startup, or it's more fashionable to say invest tech. The problem that we are trying to solve is what we like to call it as a silent killer in the retail investment space, is that retail investors today are leaving a lot of money on the table, right? Without even realizing that they're doing that, right? Because we have all been told that you can't beat the market. There is only a certain amount of return that is possible through your investment on an annual basis, right? And this is primarily because we follow the professional money management way of investment. And the big problem there is that if you look at the professional way of managing money, that is not designed to maximize on individual portfolios, right? They are designed to give a better average return across multiple different portfolios, right? And there is a good reason why that exists, right? Uh, and we can go into a very lengthy conversation, and that itself may consume the whole hour if we go into identifying what are the real problems that exist in why retail investors are not able to maximize on the return. But just to summarize why the professional way of investing doesn't really work for retail portfolios is that, like I said, the first problem is that a professional investor, whether it's an investment advisor or it's a mutual fund or any of those, right? They won't focus on individual portfolios, right? So they manage large number of clients, so they don't have time to optimize portfolios at an individual level. They have to follow a generalized template that is given to them. So that is one problem. The second big problem is that the size of the portfolios that they manage, right? So they already manage a huge amount of money, which itself makes it very difficult for them to be agile, to them to move around, move money in and out of things, right? Without really moving the market. And that is a big problem of why they have to follow a very, very slow moving process, which may act negatively for regular investors. And the big problem that happens is that most of the investment portfolios, they spend a lot less time in growth and a lot more time in recovery, right? So and if you analyze portfolios and I mean, that is a whole different analysis that we actually have, and we have been doing that for more than a year, right? The third problem that exists is the structure, right? So whether it's a mutual fund or any kind of investment fund, or even for that matter, even portfolio managers, there are certain defined boundaries within which they should operate, right? So to give a very simple example, let's say if the market is going down, as an individual investor, you can actually pull money out of the market, right, and hold on to the cash and do that. But a mutual fund won't be able to do that because by structure, they are only allowed to hold cash up to a certain percentage, right? So which means that if the market is going down, they are bound to stay invested, right? So which may not be best for individual portfolios, right? So there are a lot of those issues. Now, so what is the solution, right? The solution is, of course, active investing. But active investing is extremely hard for individuals to do, right? Because you have to analyze like close to thousands of stocks on a continuous basis to be able to find the right opportunities, identify when is the right time to enter, when is the right time to exit, right? And that is not possible for someone to do it manually. I mean, it's not even possible for even professionals to do it manually, right? Which is why they follow more standard guidelines or standard templates. Now, this is the exact problem that we try to solve with AI, right? Because a AI-based system can actually analyze this huge amount of data on a continuous basis, can identify what is the right timing for individual portfolio to generate higher returns, right? And what is the right exit point? Because again, the buy and hold is not something that really works in favor of the investment or in favor of the growth. Because, like I mentioned, a lot of time, if you just keep buying, if you follow a buy and hold strategy, would be spent in recovery rather than in growth, right? So the idea of AI is to really solve this problem and deliver a system which not only increases the return that you can generate, but also minimizes the risk associated with it, right? And that is precisely the kind of problem that we are trying to solve at Automated Returns. And our goal is to launch an app, which we'll be doing pretty soon, early next year, which allows retail investors to actually manage their own portfolio, right, in an active way, and generalize and then realize the kind of returns that is actually possible through that.
Great. Thank you so much, Ruban. This is super exciting. We're looking forward to the launch and we'll definitely be one of the early users on that, right? So it's a very interesting and a big problem to solve using AI and machine learning. And we'll come to details of how we are trying to do that in future questions. Shrikar, would love to hear a little more about Wingman, what problem you're solving and what you're building
Happy to,
using
Arjun.
machine learning AI. Thank you.
Great. Thanks, Arjun. So Arjun already gave us a little bit of an introduction there. Like Wingman is software for salespeople, which helps them make their sales pitch better. And the way we do this is by recording their emails and sales conversations that happen over different platforms, dialers, video conferencing systems, etc. And we process this. I mean, there is audio in different formats, right? Text. There is data in different formats, audio, text. We process this into insights and trends, right? So I'm keeping this vague, but I'll go into detail. So these insights are used in different ways, right? For example, sales managers can use this to drive better call coaching or deal coaching, and they can be used to connect the feedback loop back to product teams or to marketing teams. For example, product teams can look at this information and answer questions like, "Hey, what feature do I build next?" Marketing teams can use the data to understand, hey, what in my copy is working, what part of what I'm saying is actually making a difference. They can help get in suggestions for A/B tests to try out, right? These are some of the higher level objectives that Wingman satisfies today. And even the individual reps can use this to fill their context across different calls for the same deal. They can go back to, hey, I want to know what happened, what is the pricing discussion that we had. So many things, that gaps that Wingman actually solves today. And the way we do this is, like I said, is by recording all the data and converting that into text, and actually running some NLU, natural language understanding algorithms over this text. And what we initially do is we try to convert this into, we help quicker call review, right? That's the thing that most people want from the product, from our product. So they like, processing audio is inherently time consuming, right? You want to listen to a 60-minute audio, it will usually take you 60 minutes, or you'll at max you can just speed it up by 1.5 times, and that's the only way you can speed it up. But if I give you an index over the audio that you can quickly go to different sections, and this index we can build it better because it's sales specific, right? There is a lot of structure to a sales call, and what we are looking for is the structure in sales calls and helping call breakdown. And another thing is, managers have individual teams identify patterns for good patterns and bad patterns, right? They would like to track these patterns across their calls without having to review each call. And we help them, we help them accurately track these, what we call trackers. And that's where the bulk of the ML challenges are in our product, like making sure these trackers work effectively, making sure the call breakdown is accurate, and such. And to do this, like our we are essentially building and using language models, right? Taking language models to production. That is the crux of what we do in a nutshell. I'll get back to it during the course of the conversation.
Lovely. Thank you so much for that introduction. I think the sales problem is a very large problem, and I think any productivity gain and efficiency gain can be directly revenue impacting, which is what is so exciting about the problem that you're solving. Right. Going with the particular theme of today's conversation, which is the evolution of AI and machine learning infrastructure, right? Would like to kind of maybe dive deeper into each of your tech stacks today, and particularly the machine learning tech stack that you guys have. What is a typical workflow that happens within your organization, within your technical stack that you're building, that enables you to solve this problem? And if you can break it down first in a simplistic fashion, but also talk about some of the tools that you're using along the way, that will be great. Maybe we can start with Shrikar, just in terms of continuation, because you had background on, you were talking about your stack a little bit. We'll start with Srikar on that.
Sure. Yeah. So, okay, let me start with telling you what the rough structure of our ML workflow, and then I will tell you what stack we use, right? So, first, I mean, we have like data is flowing through our system. There's a lot of unlabeled data. Let me make it a little more clear. What the problem we are trying to solve is, hey, we have a piece of text. We need to build a representation, a data structure. The data structure that we use is just a vector, right? Now, from this, we have to go to a prediction to say, oh, is this what kind of what is actually being discussed here, right? Let's for simplicity's sake, let's say this is a classification problem. We are saying, is this a pricing discussion? Is this a product feature discussion, etc. Right? To generate a model for this, you'll have to first have someone look at your data and say, okay, this is a class, categorize this, right? To do this, we use, like, there are a bunch of APIs out there, like Scale, for example, is a good API that we use to use a human workforce to actually tag this data based on our specifications. Then it comes back to, we are a very small team, right? Our engineering team is like 4 people today, and the person building the model, he's tasked with the responsibility of making sure that the data is to his specifications. There is a QA process for this data. Then once it passes QA, we are using what are pretty much the DevOps advancements for models today, which is tools like SageMaker. That is what we use to actually build your model, right? And SageMaker is versatile enough that you can plug whatever platforms, whatever infrastructure like TensorFlow you want to use, PyTorch, you can use whatever, build your model, and you can, that helps you take it all the way to production and also helps you with monitoring. And this is what our stack for the model DevOps stack looks like. Now, we are too small to have a data stack for this, right? Because data is very expensive for us. We don't have automatically tagged data, so we don't have a data pipeline and monitoring yet today. So that is entirely manual, and I think some of the like as we grow, maybe that will become a big improvement for the team.
Got it, Srikar. Thank you so much. Srivatsan, maybe you can chime in on how, because you guys have been around for 3 to 4 years, you could build this from scratch, throw a little light on what your stack looks like, right? And what you use, and what is custom in-house versus what you're using that is available from in the public market. Public domain.
Sure. Maybe a good place to start is to, if I could take a minute to tell you, what is it, what is the machine learning problem that we are trying to solve, and
Sure.
in some sense, what are the challenges that we faced, especially early on, and how did that develop, and where things are at today, a little bit more maturity. So essentially, it's not hard to imagine or guess what is our core ML module, which is really an automated response recommendation system, right? There's conversation context, and based on the conversation context, you have to generate an automated response. And the challenges, probably the most critical challenges that we run into is that there is a use cases are, in some sense, they are poorly defined oftentimes, especially because we target the local business market, and they are in many cases even unknown, and so they have to be even discovered, right? And we need like in a more systematic approach to discover use cases, which is kind of a long tail. We do this through, we have humans in the loop, and we do daily, weekly AI audits and start to discover use cases which start to fill out the AI gaps. So our mantra for the for the businesses is that we are really replacing their reception desk or front desk. So we handle pretty much any call, any question, any requirement that the front desk handles, as long as it can be handled remotely. I mean, we cannot check you in person in the store, or greet you in person, etc. But pretty much anything else that you want to do, whether you want to book an appointment, make a purchase, check your membership status. I mean, or it could also be simple things like coordinating with the staff because you're running late or you're waiting outside and the door is locked. It could be just pretty much any scenario. Think about any local business like a dentist office or a spa or a health provider, where you would want to go to. You pick up the phone, you ring, and as a consumer or a customer, you have something that you want to accomplish. And because of the nature of this problem definition, the use case discovery itself becomes a challenge. And so one of the key things that we have discovered over over a period of time is how do you discover these use cases in a structured manner and start to build AI that fills those gaps. And that is one of the things. The other thing, the challenge that we face is not only are the use cases unknown, poorly defined, we literally have zero labeled or unlabeled training data to start with. I mean, this was 3-4 years ago. You can talk about publicly available data sets. You can talk about, I see a question there on the live chat about GPT-3. These things are around, but these are very domain-specific conversations. And GPT-3 or any of these other data sets are not going to help solve that problem in any direct way. We have to integrate with the backend software, the booking provider or a point of sale system to be able to pull menu of services, products, pricing information, all of that, integrate with that, and then provide the complete experience. So we really literally have zero labeled or unlabeled training data to start with. And for us, we simply needed to bootstrap that data. Just like, I always say that startups need to not only bootstrap from a cash perspective, ML startup have to bootstrap from a data perspective also, in that they literally start with zero data. They deliver, epsilon value, generate X data, then use that to generate 2 epsilon value and then go on top, right? And literally, now millions of calls later, we are now generating more data than we can use. So, we are now on the other side of the spectrum as far as data is concerned. And, monitoring performance drift remains a key challenge. Even today, it's a very difficult problem. I'll talk a little bit more about it. But if you think about our, with that background, if you want to think about what is the, our tech stack, really, we build our conversational models ground up using TensorFlow based, neural networks, that architectures that we've designed in-house. And what we do is we have, we lean on some pre-trained models like, let's say glove embeddings or word-to-vec embeddings, things like that. But the neural network itself is developed and implemented in-house as far as we are concerned. That is completely something that we develop in-house. We use some elements of open source NLP pipelines like NLTK. We do use a Google Voice API to do speech to text, but these are few and far between. The bulk of the tech stack itself is built ground up in our case, because again, the reason is that we require to have that level of control to deliver the experiences. I'll pause there. And hand the baton around. You can happy to answer more questions as the next
Thanks,
cycle.
Yeah, I think that's valuable to understand how this has evolved and what are your key challenges, right? Maybe that's a segue for me to go to Ruben to say, because you're just starting off and maybe it's been a few months, maybe less than a year, as far as I understand, that you're building your stack and you're yet to go live, right? What are variables and what are considerations that go in for you to decide what you're using as a stack, right? And throw some light on the complexity that you have to handle. We of course heard from both the other panelists about the data complexity. I'm assuming there is certain similar data complexity at your end, but just talk about so early in your life, how do you decide what stack, what workflow, what infrastructure to go with as a ML AI startup?
Right. Yeah, I think that the challenges that we face to a large extent, we do have similar overlaps with what everyone is facing, right? Um, and there are certain unique characteristics given the domain that we are in, right? So let me start with the biggest issue, right? So which is also the kind of the pitfall that we have to avoid, right? And it's a standard thing that in case of any machine learning problem, any data science problem, data is the key, right? Because the standard is garbage in and garbage out, right? But in our case, it's garbage in and financial losses out, right? So we have to really take care the cost of data being not proper, right? And that is the biggest challenge, and which is why a large portion of what we have to do or our workflows are around ensuring that the data is right, right? And we don't have a single workflow. It is like a sum total of multiple workflows that work in parallel in conjunction, and these are like more event driven workflows. So when it comes to a data integration kind of a workflow, so we have to collect data around, say, prices of stock prices, around companies' financial filings, the news, the social media, right? And there is no one standard way of scheduling and getting this data from, right? These are all happening at various different times. So we have to ensure that as and when things happen, we are there to collect the data, right? The most important piece of the data post data collection is the data prep itself, right? That we have to do to make sure that we are able to extract the right insights that we are trying to get to, right? A very simple problem, like say missing values, right? So missing values in data, in our case, we have to identify, is it what is the right context around that? Is the data missing because the market was closed? Is the data missing because the market closed early, right, during the day? Or is the data missing because the stock got delisted, right? Or is it because there is actual problem with the data itself, right? So we have to figure out all those contexts and do it almost like dynamically on a real-time basis, right? And then, of course, we have to go through the regular process of feature engineering, of normalizing the data, right? So that we are actually able to uh, able to guide the model to extract the right values, right? So there is a lot of contextual data prep that we have to do, right? I mean, to solve various different hypotheses that we need to solve to get to the final goal of how do we identify the right opportunities at any given point of time, right? How do we identify the right entry points and right exit points? Then in terms of our production workflow, the production workflow is essentially that. It's about identifying the opportunities, which is like ranking different stocks based on different criteria, identifying the patterns and anomalies to know that when is the stock behaving as intended, or when is the stock not behaving as per the intended, right? So the anomalies could either mean that there is a problem or it could mean that there is an opportunity, right? So we have to learn to differentiate those, and that is where the whole the machine learning aspect comes into play, right? The other challenge is on the modeling itself, right? There are certain things that we can do offline modeling. There are other things that we have to do online modeling, which is like as the data comes in, we have to continue to learn because certain things change so dynamically, right? So, for example, the market environment could change, right? The stock itself could go through various different changes because of some new mergers and acquisitions that they did, because of some big news that came up where the whole behavior of stock prior to that event and post that event might change dramatically, right? So we have to account for things like that, right? And one of the biggest challenge that we face in our domain is the signal to noise ratio is extremely low, right? There's just so much of noise and very little signal that extracting that becomes a very challenging problem for us, right? So which leads us to the experimentation workflow, right? So we have to constantly test out various different hypotheses, right? And sometimes these hypotheses are not even along the same lines, right? So we have to come up with, very different ideas and explanation of what could move a stock, right? And often they're not even standard things. It's not on how the company performed, but it's a lot of the external factors that we have to account for. And for each of the factors, the behavior of the stock could be very different, right? And how the stock behaves in the short term could be again different from how it behaves in the long term, right? Which also means that we have to model the horizon that someone is looking to invest very differently. The opportunities when you are looking to invest for 5 years is very different when you're looking to invest for a year, or when you are looking to turn your portfolio around more frequently, like on a monthly basis, right? So we have to take all of those into account. Each one of that leads into a different set of experimentation, different hypotheses. Each one of them generates a different pipeline, right? Right from getting the data, right from identifying how to feature engineer the data to solve that problem, how to generate the models. How often do you update the model, right? And then finally, we need to have a monitoring workflow which not only monitors all other workflows that are going in to make sure that they're all running properly, because we have just so many of them running at any given point of time, and anything that misses means that your whole computation, your whole calculation goes for a toss, which also means that we may not be able to give the insight at the right time. We may not be able to identify the right entry, right exit, or the right opportunity, and which again is a problem, right? So we need to monitor our workflows, and more importantly, we need to monitor our models on a constant basis to identify when is a model degrading, right? Because it changes so fast, right? The environment is such that it's constantly changing, right? So those are some of the high level challenges. Now, when you dive deeper into the machine learning problems, right? So again, we run into data quality issues all the time, right? So whenever we are aggregating data from multiple sources, not not because of the source itself, because of the nature of how the domain operates. For example, financial filings, right? A company may file their annual returns, and they may then file another one to correct some of the things in their return or update those things, right? And they happen after. So which means that once you have processed the data, you have to reprocess it. You have to make sure that it's current as the filings are happening. So we have to constantly look out for is that when the data is changing, right? And ensure that we have the highest quality data at given point of time. I talked about the signal versus noise, and how it translates into the modeling problem is that we have a huge class imbalance when it comes to training, right? Because the number of positive cases that we need is very tiny, and the negative cases are very large, right? So we have to really get creative of how we work around this problem. And it's not just about saying that you just artificially bloat up the cases, right? Because you also want to ensure that you're capturing different market scenarios. Because if you're training a lot for a single market scenario, you may not be able to identify things when the market changes, right? So we have to plan ahead of how do we generate the data that not only covers the scenarios that we have seen, but can also account for scenarios that could possibly happen, right? And that has not happened yet. Um, and in all of those, the other challenge that we have to ensure is the infrastructure management challenge, right? Because the compute is not happening all the time, right? And there are like bursts of compute that happen. There are certain times when, yeah, when you have the quarterly earnings coming in and all of those, which comes around the same period of time where there is a lot of processing that happens around that, versus that there are other periods where the processing is less. So we have to scale up and down our infrastructure dynamically as well, right? So there are all those challenges, which are similar challenges that everyone faces, just that uh, almost like every challenge that you can possibly think of is applicable in our domain, right? And which is why it magnifies the problem that we have to deal with.
Understood. Thank you. I think that's an interesting segue or an opportunity to talk about the tools that are available in this ecosystem. And I'll come to you, Shrikar, right? You have worked at larger companies, right, that have a lot more resources, right, both in terms of people as well as infrastructure, in terms of building stuff in machine learning and AI. Now you are at a resource constraint, in a resource constraint environment of a startup, right? There is this wave of what we're hearing to be called as ML ops and ML infrastructure startups. They're SaaS companies building tools that enable all of you to do your jobs better, faster, more efficiently, right? And we heard some of these contexts, all of three of you brought up in terms of, it could be in data preparation, it could be in training, it could be in feature engineering, it could be in then monitoring, right? Can you throw some light on what tools do you use that are available, from that are SaaS companies, and what do you feel that you have to build in-house for certain reasons, right? Just talk a little bit about your MLOps toolkit, so to speak,
Got it.
right? And also, if you can throw some light on your experience from what large companies have a benefit and therefore small companies have concern about.
Great. Okay. So let me start with adding some structure to data ops and machine learning, right? So when data ops came in for engineering, right? So they were talking about what is the process where you code, how does that you need to have a repository source code. From there is continuous integration, then there is a test process, then there is a canary and all of this, right? Now this didn't exist for machine learning for until the last few years now. But even this DevOps, I think, can be divided into like two broad things. So DevOps for models, right? Like what happens, how do you retrain models, how do you maintain model versions, how do you take them from development to production quickly, right? So because for example one way to think about that is, if let's say the set of tools that data scientists use to and the set of tools that can actually be used in production, if they're different, then there is a disconnect, right? There is nobody owning the whole piece, so the data science doesn't own it till production, at which point there is a state where the model just doesn't get updated. And the biggest problem that this causes is data drift. I think Srivatsan mentioned this briefly, right? And this is the problem that these are the tools we adopt tools to specifically counteract this problem. So, for example, let's say our transcript.
Good idea if you can define what data drift means,
Yeah,
just
I was getting to that.
and
I
then
was
you can
getting to
dive.
that.
Okay.
Yeah. So I'll define this with an example, right? So I mean, machine learning systems are not really truly sentient systems, right? They're identifying patterns in what they've already seen. Now, let's say your underlying data distribution changes. By distribution, today the algorithms are not really looking at what you would see as patterns. They might be looking at an entirely different pattern to make their own decisions. So those patterns might be focusing on some errors in your transcript, some noise in your data, etc. Right? Now, as long as they work to your specifications, that is good. You can most systems are opaque. You can almost never tell what they're actually looking at, to a very high degree of accuracy at least. Now, let's say we in our case, we our models are built on the output of a transcript from some system. Now, let's say this transcription system changes. This could potentially cause your older models to break because they might be looking at some idiosyncrasies in your older transcripts, right? And let's say you're onboarding customers from a different geography. Today, our transcripts look very different for Indian accents versus US accents. that could cause some fundamental shift in the models. The models will need to be retrained, or you're selling to a different audience, a different vertical altogether. Today, most of our customers are in the finance space. The conversations look a certain way. Let's say the conversations are in some other space, let's say automotive or SaaS, right? They will look different. So this is what is data drift, right? This is organic, fundamental, real change in the data that your models need to account for. And to solve this, you need to have a clear pipeline that enables people to take models from training to production in an algorithmic manner, right? The DevOps tools for this today are tools like SageMaker on AWS, and there are a few others, but SageMakers haven't explored a lot beyond SageMaker. Then there is a different problem that people are building tools today, like for data pipelines. I mean, you might have heard of the term feature store, right? So this is pretty much what my team at Uber built, and that has actually grown into a very big company in the last 2.5 years, right? Phenomenal growth. Tecton is that company. And what feature stores do is they help you share, collaborate, and maintain feature pipelines so that there is no drift between training and production, right? This is the kind of tools that we don't adopt today because we have data which looks different compared to a lot of these companies. And the tools that we use today are primarily in maintaining your models and monitoring your models, monitoring the distribution in your models, and all of that. Like takeaways from working at bigger companies have much more custom solid processes because they have the resources to invest in making sure primarily they have to enable communications, right? Let's say a scientist sitting in team A thinks he can use some data generated by team B. Bigger companies enable this communication well enough so that you can I'm only talking about the few big companies that I've been in. This might work different in different enterprises, but at least at Google, an engineer sitting in one team with their 20% project could openly approach another team and convince someone that, hey, let's work on getting this data into a format, and I think we can build a model to generate this outcome, right? That wasn't very hard. But in companies where teams work in silos, this might get really, really hard. But here, data sharing was very easy, and those principles, unfortunately, I don't know how easy they are to adopt to startups. But at our scale, this is not a concern at all.
Understood. That's very useful insight. Srivatsan, part of the same question to you. For your evolution, what did you and your team use in the early days, right, of building the stack, and how has that changed? How much in-house, tool building, so to speak, have you had to do, and what has been your learning and insight from what are many more tools available today in this entire stack?
Absolutely. I think, we see three components. I mean, not anything different from what Shikhar mentioned some time ago. We really see three areas in the ML ops for us, right? So there is the data preparation, there is model building and monitoring. Right? So we kind of break that into three broad buckets. And data preparation has two parts. One is preparing data for annotation, right? So that itself in and of itself is a task. So and then there is the data preparation for training and testing models. And so these are two different things. And over a period of time, we've started. You have to index your data with materially searchable. Figure out what are the key what are the key those searches you to be able to find the right data files and at any given point to be able to make the associations between different versions of data as it passes through the data prep pipeline, right? So that is key. The second thing that we have seen is that, again, this is um, I'm giving you a specific example in our setting, but I'm sure there are parallels in pretty much every machine learning startup. The data becomes stale in that, especially when there are external dependencies, right? You're looking at a DB for, let's say in our case, menu of services or staff information, staff names, and things like that. And these things change. Their products are different, the services are different, the staff names change, and because of that, data that you collected 1 month ago is not usable because the external dependency has changed. The database itself has changed, and so you're not even able to effectively utilize that data to pre-process, and label it, right? So from that context, for example, when somebody says, I would like an appointment with Dr. John, if Dr. John is no longer at the clinic, the entity model is going to throw, an unrecognized entity, right? And so you're not able to process from anywhere. So that way, data gets stale. So what you want to do is, you want to be able to keep this, keep data snapshots current on a regular basis. And from this point of view, we had purely a data preparation standpoint, we started off with spreadsheets. So we would annotate data using Google spreadsheets. It used to be painfully slow to scroll, thousands of lines of data. But it started to really hurt. If at some point it starts to hurt, and you'll always feel that pain. It'll pain really badly. And then today, we're actually spending a couple of $100 a month on a third-party tool for annotating, conversational data. And the cool thing is, we've found a really good tool that meets our very unique requirements. Like, we have a hierarchical labeling requirement that this tool is able to provide. We use a tool called Datasaur, which is a relatively new. They are also a startup, but it's an excellent tool for conversational annotation. On the model building side, there is the developing. You always have the choice of either develop a new model or pick from a model library. Time and again, we hit frustrating limits when you pick from model libraries. Even simple things like, our own internal experiences have been simple things like name detectors, which you would think that, oh God, that must be a really well solved problem. But you look at publicly available APIs from model libraries, you'll find very poor accuracies and actually embarrassing results. So you then have to start investing in. So our experience has been that when you use these types of pre-trained models, there are very strong limitations, and controlling the quality and accuracy starts to become problematic, and then you start to build it on your own. The On the monitoring side, one of the things that we found, drift is always, Srikar talked about it as well. It's always very tricky to measure. Because especially in our case, what is, it's live. In the live data, there is no real way to tell whether this was the right response or not. You will need to identify and track effective proxies for accuracy, right? There is a notion of what is an accurate answer if a human were to actually label it. But whether the task got completed, or was the task did the task hit failure, and did human in the loop intervene, or did they provide input? These kinds of sort of proxies for labeling, for measuring drift, become very important. You can't directly say, oh, precision recall or F1 score or something. That is what I'm going to measure. You won't be able to measure it in live data, just because it's flying by and there is no way that humans will annotate at that speed. And the other thing, very, very useful trick in the book that we use, and I've been using this in my machine learning all my career, right? Since my days at Microsoft, is to use deny lists and allow lists, right? It's the fastest way to patch a bad model prediction. So if a model prediction is poor, find the pattern, put it in a deny list, and forget about it until the next time you retrain your model. You keep building this and you keep monitoring live data. And by building deny lists and allow lists, you can very effectively get bootstrapped with quality data, and then slowly, a time will come when these lists are large enough, long enough, and then you'll have to retrain those models and so on. The other thing that we have found as relevant and necessary is that every time we build a model and deploy it, we worry about whether there is going to it's going to impact any average peak memory, inference during inference, and whether it impacts our latency, it impacts latency, inference time, and we always have a fallback path in our code. If the ML server either refuses to give an answer in a timely manner, or provides, or it crashes, or it provides, it throws an error in some sense, you have a fallback path where the system is still able to complete that user experience. Maybe not as well as it should, but there is always a fallback path. So for us, those are kind of the three key components in the ML ops, and that's how we start to think ground up slowly. Start small and then start to grow bigger and bigger. And I do have some thoughts on build versus buy. For SaaS service, I'll come to that when.
Maybe you can start off with that, and I'll take that same question on to the other panelists as a follow-up. Why don't you go ahead?
Sure.
How many tools and how do you decide, when you really need something? Please, that is a good discussion.
Yeah, I mean, I see there are really, it's a bit of a flow chart in my mind for build versus buy, right? So I think of it as a 4-step process, right? You have pre-trained models which are ready for inference, no training needed, no data needed. But then you have to ask yourself the question: do you have domain-specific data? Does that data really matter for your decision making? Are you worried about possible bias in the data from where these models were pre-trained? And if the answer to any of these questions is yes, then yeah, pre-trained models is not for you, right? For example, in that example that I gave you, we had better domain-specific data to train our name detectors, for example, right? And so pre-trained models had to be thrown out of the window. The second step, in that hierarchy is from pre-trained models, you go to, the buzzword of 2020 maybe is AutoML, right? So, automatically train a model, give it your own data, and just tell it a learning goal, and it'll go and try various different models. It will do, it'll try different feature combinations. It will try, a lot of parameter tuning. But then you have to ask, sure, that is an option. And Google has some very strong AutoML libraries, services out there. So does Azure and AWS. AWS to a lesser extent. Maybe I'm not fully familiar, but I know that Azure and Google both have pretty strong AutoML solutions out there. The question there is, do you want to control the featureization? Do you want to control model selection and parameter tuning to the point where you can say, hey, no, that single learning goal is not going to cut it for me. I need more granular control over the data. So then the AutoML goes out the door as soon as you feel that you want to control featureization, model selection, and so on. And again, the other big question with AutoML is, are you okay transporting your data to those servers, right? You have to pass. Imagine I have a conversation at a doctor clinic, and I have to pass that data through the ML servers and return it. And I don't know to what extent those data may be used by the AutoML to serve other customers. I don't know. I can't be sure. I have to look at the fine print there. How do they use that data? I need to really know before I want to invest in an AutoML solution. The third, and then in the hierarchy, is the what I call the out of the box algorithms, right? So you don't want the headache of building an LSTM, or building a support vector machine, or building a decision tree on your own. You don't want to write that code. These are out of the box algorithms that are available. You can train on your own data. You can control featureization, model selection, tuning, and you can of course run it on your own servers. Then and you obviously need better quality AI ML engineers in your team to be able to address these problems. But more importantly, you have to ask the question: do you need innovation in these model architectures? Is it, double check? I mean, is that innovation necessary for your delivering the promise to your customers? And if the answer is yes, then out of box algorithms will then start to look like standard benchmarks, and then you compare against them, and then your own internal solutions are better. I mean, for example, I can give you one example. We started off back in the day by building by using the most popular time detection a time entity detection algorithm that's out there, which is by Stanford, and and slowly what we realized is that it makes systematic errors. There are and those systematic errors, if you want to fix, you have to get into the code and do dirty lots of get into the weeds and start to fix, write lots of wrappers and exceptions to handle that. And then at some point you tear your hair, and then you say, I'm not able to get it to recognize the simple thing such as Sunday 4 p.m. or 5 p.m. and then, oh my God, I need to build my own time detector. So then today we have, I would like to believe, state of the art, time detection solution within the company. Easily, when we did our last benchmark test, we superseded the performance of the Stanford NLP time detection, right? So that's an example of where you start with an out-of-the-box algorithm, and then you hit the boundaries of what it can achieve. You in some cases you're able to patch for your use cases. In some other cases you hit frustration, and then you have to go forward. And then the final in that hierarchy, and that requires probably the least explanation, is build your own, of course, right? So, and TrueLark well and truly falls in that bucket. And of course, frameworks such as TensorFlow, PyTorch enable you to very easily develop new model architectures. But the most important question there to ask is, do you have the right team, and do you have enough time to take that approach? And you can only do that if ML innovation is critical to your core business model. If that is not the case, if that innovation is not core to your business model, then you really need to be looking at one of the first three solutions, whatever is suitable. So I like to think of this in this cascade of four steps between pre-trained models, auto ML, out of the box algorithms, and build your own. And that's my few minutes on that topic.
No, very insightful, Srivatsan. Thank you. We are at the top of the hour mark, so we will, start blending in some of the questions that are already coming in from the audience. Right, I can see a couple of questions which are a good extension of what we're talking about. We spoke about monitoring. We spoke about the errors in the data. I think Ruben referred to, and the consequences of that in some sense. Right, that's a good context for us to talk about ethics in AI. Right, basically we're saying monitoring, observability, and explainability is starting to get a lot of attention, a lot of importance, and rightly so. Different in different contexts, right? And therefore you need tools and systems and workflows and processes, I'm assuming, to do all of that. Ruben, if you can talk about how you're thinking about this. Still early days, not yet in production, but I'm sure you are starting to keep this into mind when you want to when you're building your systems and your workflows. Can you talk a little bit about your observations and your insights into this aspect?
Yeah, and I think the explainability of the model is a very, very important factor, especially in the financial domain, where it's very hard, and more so because we are dealing with extremely high amount of noise and very little signals. So we have to be extremely careful that the models are not trying to learn from the noise itself, right? And if we go with a very, very black box approach to deploying the model without even trying to understand why did the model pick or make a certain decision, right? And that is one of the very, very important criteria that we focus on. And there are like newer startups that are coming up. So one of the companies is a company called TrueEra, and who is trying to solve this specific problem, right? So how do you make AI models or make it easy to explain AI models? From our perspective, the way that we try to do it is that we have or we had to write a system around trying to understand every decision or the every selection that the models are doing, right? So when they are picking a certain set of stocks, we go ahead and try to dissect that and try to figure out what led the AI to decide, right? So what were the factors that were given importance for, right? So we try to understand the decision process, right? So we try to create multiple different types of models, going from a very simple linear regression all the way to complex neural nets, and try to see how, with increasing complexity, how is the decision changing over time, right? So we have to try to figure out all or slice and dice the decision from multiple different angles to make sure that we are comfortable with the way that the models are selecting things, right? And it's even more important because any like I said, the cost of a wrong decision is extremely high, and we need to be able to justify to the end users as to why are we recommending a particular stock, right? Or why is the system recommending? I mean, we don't recommend as individuals, but we are actually recommend the system is recommending the stock, and why is it picking, right? So being able to explain that is very, very important for us.
Got it. Got it. Shikhar, continuation of this question to you. What are you doing in terms of observability / explainability? Does that also impact your, data, preparation, model training, the previous aspects, to be able to finally in production to be able to get some insight when you need it of what went wrong or what went right? Just and again, if you can talk about tools that you may be using off the shelf, or are you building something in house?
So, okay, the answer for this is not really in our tools, but in the kind of algorithms we use, right? The class of algorithms that we use, they do their best to spit out the explainability information. What are they looking at to make this decision, right? But none of the algorithms that we use today, or the current state of the art that I know of, have great observability, right? They're very, very approximate. In fact, from what I knew, in the early days where teams were adopting ML, they're like, for example, Google search notably didn't use ML for a very long time, until as recently as 4 or 5 years ago, right? They were rule based because of how much control, how core it was to their business, and how core explainability was to them, right? And the kind for us, the cost of an error is not as critical as what Ruben is saying. So we sacrifice those for potentially better performance and ease of model building, right? What our focus is in, we're a young startup. We have the problem that Srivatsan mentioned, right? We need to bootstrap with data. Some startups have the flexibility of I'm guessing TrueLark generates its data using heuristics, because okay, based on how the user reacts, whether this is a good reaction or a bad reaction. We don't have that, so we need to collect our data. So we are trying to use algorithms which are one shot or few shot learners. So because of that, our focus on observability is less, but most of that is through the class of algorithms we use.
Understood. Understood. There are a bunch of other questions in the group, but I'd like to use one more next, and a quick, maybe a 1-2 minute view from each of you, particularly talking about what do you see happening in this ecosystem, the machine learning, AI, tech stack, infrastructure stack, and probably on the algorithm sides also next 5 years, right? What are you're seeing? And because you guys have seen history, right, and have been close and been tracking it and working in the ecosystem, that insight will be very valuable. Are we on the cusp of something, right, on certain very big problems that haven't been solved? Of course, somebody asked about the GPT-3, right, in the chat also, right? Just a quick 2 minutes, view what's ahead. What do you think is going to happen, right? And what's going to be interesting breakthroughs, in your opinion? Would love to hear. Maybe Shrikar, you can start yourself, and then we'll go around the table.
I think I think the interesting breakthroughs in my mind will come from being able to train larger models. That I think are going to come from less from better architectures, because they are far and few, and more from more specialized hardware for ML. And I think that is what is happening today. For example, GPT-3 is less about an incredible architecture and more about how many resources one is able to throw at the problem and get towards the one shot goal, which is what I think in our conversation from 3 years ago, that's what I was telling, like if there is a goal that I had, that would be like creating better few shot learners. I don't tell my kid, don't give my kid 100 examples to learn something. So it's from much smaller than that. And I think we are going to get incrementally closer to achieving this goal.
Very cool. Srivatsan, thoughts on this? On what's ahead? What do you think is going to be breakthroughs in the overall?
I mean, I would say that, I mean, the, probably, two things, both of which we spoke about briefly, but two things are going to see, the quality of AI and ML is just going to keep getting better. I mean, now we are it's a point of no return, right? So, society is going to be in the grip of AI, and it's not coming out anytime soon, no matter what anybody thinks about it. So really, I think there are two elements of AI, or two broad areas of AI, that's going to see a lot of attention, both from the research community as well as from the community, from the industry, is going to be centered around transparency and observability. I mean, if you think about observability, I would not really mix observability with ethics. I mean, they're slightly different in my mind. I would keep them separate. In just a moment, I'll tell you why. Observability is really focused on delivering the performance that you're trying to, optimize for, and it helps improve adoption and deliver greater experiences. And we'll now see better tooling to be able to do this in live systems in real time, right? Better tool sets to monitor, like I said, the proxies that I was talking about, to be able to and then use those to drive retraining and so on. Already there's quite a lot of that in ML pipelines that are available from the big players, and we're going to see more of that with greater control. On the other side, and where I think you will see some form of a breakthrough, almost certainly over the next year, couple of years, even in that short amount of time, is in around the concern around the ethics of AI, right? We are going to see, and this is not just a technical problem to solve. This is a socio-technical problem, I mean, if you want to call it that, right? And we are going to, the community will come up with a consensus on what it will take, to clear an AI model for ethics, to what it will take, what is going to be the framework to even today. We don't even have a way to address these issues in any systematic manner, and people are working on this problem. How do you define the axis along which ethics of AI can be measured for an algorithm and so on? So I think there we will see breakthroughs over the next 2 to 5 years.
Lovely. Ruben, what is similar? What is
Right.
different?
I think
Go ahead.
Shrikar and Srivatsan have touched upon some of the most important points that are likely to happen. Let me add to a very different issue, right? And it is, I think it also would answer one of the question that has been asked around what happens after training a model on a beta in the real world scenario. Yes, that needs to, and it's already happening and will probably continue to happen, is around data simulation, right? And and that is so far has not been as actively pursued topic, but it becomes even more important to address specifically those challenges, right? So what happens when you're training with a very limited amount of data and your real world scenarios are different, right? Or it's a larger superset of that data, right? So how do you generate simulations? How do you put in scenarios that could possibly happen, but you don't have the data for it, right? So how do you generate those kind of data? How do you generate those kind of simulations where you can actually test out how the models will behave, right? Or how the system would behave, which also touches upon some of the other aspects. I mean, it kind of borders around the ethical aspect as well, because with those simulation, you can also test out scenarios of how an AI would behave in certain contexts, right? Which kind of borders around what is ethical and what is not, right? So I think that whole aspect of data simulation, although it sounds like a very simple thing, but it's actually not. And I think there is a lot of work that needs to happen around that, or a lot of emphasis that needs to happen around that, and it's already happening actually.
Makes sense. Very exciting. I think there was one question in the questions panel to talk about, in general, the costs associated, right, with building machine learning companies, products, and therefore companies, right? The headline seems like there's obviously the data. You need more data that makes your models better, and therefore you perform better. There's a data cost, data gathering cost, data labeling cost, right? But there's also then training, model training, infrastructure costs, right? Compute costs, right? All of you have your constraints as early stage startups, all right? How have you dealt with this challenge? What are you observing? What else would you like to happen within the ecosystem, right, for this to get better and this to be more achievable and accessible for startups? Because that's where we keep hearing about the skew between large companies and small companies, and the gap gets wider and wider because they have the resources and they can keep getting better while the smaller companies are strapped, right? Thoughts on that, Shrikar? You're also thinking about infrastructure costs. I know from our past conversations, how does that come into your consideration set? And talk about costs in general for an early stage startup in this world. Shrikar, you are on mute.
Sorry. So the question is around how do you deal with infrastructure costs for ML systems and
Yes.
yeah.
Yes.
So
Overall cost for your entire tech stack and your ML systems, right?
so
You are at a disadvantage compared to large companies. Are there ways that you can solve that?
I think so. I think most of the cost, the disadvantage that we face is not due to infrastructure. I mean, there is cost due to infrastructure. I'll tell you how we handle that. But there is also cost due to data collection, right? That is more expensive and fundamentally more time consuming. That you just can't pay your way through it as fast as the bigger companies have been able to achieve, right? The answer lies in the choice of algorithms, and like we are constrained by what kind of models we use, what kind of algorithms we use for that. So we have to the real answer for all of this is building on work that people have done before. This is transfer learning, right? That's what helps us reduce the costs, our ML costs. Like we can't afford to pay $4 million to train an excellent language model to serve our purpose, right? But when you trade that off, you get a slightly worse model, but you reduce your cost significantly, like many orders of magnitude. That is how we handle costs in ML today. And again, the what would have required thousands of examples, like tens of thousands, with the choice of right model, you can reduce that down to like hundreds, right? A couple orders of magnitude at least. So this reduces our infrastructure costs as well as data collection costs. But again, it might come with some degraded performance, but the research says that it's not as big as one would think, or what it traditionally used to be.
Useful. Shivatsan, a point on costs and how you have seen that evolve and any solutions that you have employed at TrueLark?
I can't. I mean, I don't think I have anything very different to say than what Shrikar pointed out. I think if you look at if I were to think back, I think the challenge for us was always, I mean, one of the line items in our monthly spreadsheet is always the human annotation cost for human annotators. That is significant. And the only thing is that we are generating data that nobody else is generating, and over a period of time we are well and truly systematically step by step, brick by brick, building generating very high quality data, and consequently that's feeding higher quality models. I don't think we are being hit or burnt or troubled by ML infrastructure costs today per se. I mean, that's not bothering us in any significant way, particularly because we don't use any, we're not paying any API fee or for pre-trained models, or we're not using any for example, we don't use AutoML or anything like that at this point. So we don't even run into those costs. So even though our volumes may be high, running into millions of calls per year, we don't have to worry about those kind of costs scaling up, because all of that is actually in-house. Most of the problem that we face on the cost front is really in data annotation. We continue to face those problems. We try to outsource this. We have teams sitting in Africa. We have some teams sitting in India, trying to do this for us. And it is an operational challenge, but I think it's one of those things that you have to overcome.
Useful. Ruben, any unique insights early on in your journey on the cost?
My answer is very similar
Are
to
you
actually
think you can
Shivatsan.
guide it?
Is that I mean, we haven't encountered a large cost due to AI and machine learning training per se, because thankfully our models, although we train a large number of diverse models, but the models in itself are not like the language models or the video models either, where the cost of training is very, very high. So we are able to keep that. I mean, the cost of training is much lower from that perspective, right? And for us also, we have a similar problem, is that the data is much more expensive, right? Because you have to pay the exchanges a huge amount of money to get the data. You have to pay different data providers. So and data in the financial domain is like is I mean, is being charged much higher, and for a good reason. So our data cost actually outweighs the infrastructure cost that we are paying. But having said that, I mean, there are definitely some of the creative solutions that we are trying to put in. Although we can't really use concepts like transfer learning from external, but we are trying to see that even internally within the data, because we end up like training models on a per stock basis to understand every individual stock behavior, but we try to see if there is a closed mapping that we can draw, and can we apply something similar, a concept similar to the transfer learning here, by kind of grouping similar stocks or creating similar buckets that gets trained together, right? And the other thing that we are trying to optimize in is the optimized use of infrastructure, because like I said, that our training and the processing comes in bursts, right? So how do we like manage that dynamic scaling is what we are focusing more on at this point.
Lovely. I think there seems to be a commonality there to say everybody's saying the data part is quite challenging, and there's costs as well as the operational effort that is involved, which is one of the key challenges for an early stage AI machine learning startup. Maybe a note for entrepreneurs to take away and say that's a problem still to be solved, and can you get innovative and see what you can do there for entrepreneurs in the audience, right? So thank you all of you for that, right? I think we are at 1 hour 25 minutes. I think we'll use this as a wrap up point. Was very engaging discussion. Definitely for me, learned a lot. I think we could go on and on specific aspects and go deeper and spend more time as well. But hopefully there's a part 2 to this sometime in the future. And maybe that time all of you have evolved and there's, from here to then we can talk about that journey as well. This was super, super insightful for us at SpecialeTalks and for hopefully the entire audience. So thank you very much to our esteemed speakers. Srivatsan, thank you so much for taking the time out so late in the evening in your part of the world and sharing your thoughts. Ruben, likewise, super excited to see what you're building and wait for the product to get live. Thank you for taking the time out late in the evening as well. Shrikar, lovely as always, right? Thank you so much for your time and unique insights on how you're building Wingman. All the very best also to all 3 of you startups, and thank you so much, right, from SpecialeTalks.
All right, take care, everybody.
Take care, everyone.